Now dipole-dipole interaction. Dipole-dipole interaction. Let first is the meaning here is that find the torque and potential energy between two dipoles kept parallel to each other at a distance r. It means we are having, these are the two dipole moment of these dipole your P1 and P2, and gap between the dipole is your r. See, whenever dipole-dipole interaction we have to find, so we will use the basic definition first of the potential energy relation, that here minus P dot E, and from here torque relation we can get. Torque is equal to, as we know force for electrostatic means for conservative fields, we can write force is equal to your minus of du by d theta dr. Similarly, for conservative torque or torque due to conservative field, we can write torque is equal to minus du by d theta. From that we can get the all idea. So in all the problem we would like to do this type of things first. First we will calculate the interaction energy. In interaction energy, minus P dot E, P gives the dipole moment of one of the dipole and E is the electric field of the other dipole. Any of the dipole can be taken as the first dipole and other dipole can be used as a source of electric field. See, let dipole P2 kept in the field of P1. Let dipole P2 kept in the field of P1. So location of P2 is the equatorial position of P1. Location of P2 is equatorial position of P1 is equatorial position of P1. In equatorial position, see. So electric field due to P1 is your in this direction. So potential energy U is your, see, in equatorial position of P1, and so field at equatorial is given as 1 by 4 pi epsilon naught P by R cube. This is the field relation, or better we can say here P1. So field on equatorial position is given as 1 by 4 pi epsilon naught P1 by R cube, and direction of field your opposite to direction of dipole moment. See, so dipole moment direction of dipole P1 is this. So due to this dipole, field on P2 will be this direction, and magnitude is given by 1 by 4 pi epsilon naught P1 R cube. So potential energy, so angle between P2 and E1 your 180 degree. So from here minus PE cos theta, so theta is your 180, P1 will be your, so minus P2 E1 cos 180 degree, and this written as P2 value will be here P2 and E1 is your 1 by 4 pi epsilon naught P1 by R cube. Okay, so potential energy is written as 1 by 4 pi epsilon naught P1 P2 by R cube. So from here we can determine the torque. F is equal to minus du by dr. So here torque can be, force can be determined minus du by dr, and now after simplifying we can get 1 by 4 pi epsilon naught 3 P1 P2 by R cube. And now if we want to calculate torque P cross E, so here also we can calculate torque. See here, if we are calculating torque, since electric field in this direction, dipole moment in this direction, angle between these two your 180 degree, so net torque on this is your 0. So this is the conclusion here. It means when two dipoles are kept parallel to each other at a distance r, so potential energy of dipole is given by this relation. From here we can get the force by writing this expression minus du by dr 1 by 4 pi epsilon naught 3 P1 P2 by R cube, and net torque also we can calculate. See the another example, the same way we can say the another question here. So find the torque, potential energy, force between two dipoles kept perpendicular to each other. Kept perpendicular to each other at a distance r. It means right now the situation is like this. Let this be your one dipole moment is P1, and another dipole have dipole moment your P2. It is kept like this. In the same way we will calculate again. As we know, potential energy is your minus P dot E. Now we will calculate how much is the force and potential energy. See, due to the P1 here, if we are looking, this is at equatorial position, so electric field here in this direction. Electric field here in this direction. So angle between P2 and E1 is your 90 degree. So as potential energy relation is your PE cos theta, so here potential energy between these two is your 0. Potential energy is equal to your 0. Now if we are looking the forces, see for the force. If we are looking the forces, so some different approach we have to follow. See, this is your dipole moment your P2. So variation of electric field we will see here. How the electric field vary? So P2 is your written as Q into 2 dr. Dr is this, and dr is this. F is written as, first we would like to force F is your Q into E. So first we would like to calculate E, how the electric field vary. So E at equatorial position is given as 1 by 4 pi epsilon naught, 1 by 4 pi epsilon naught P by R cube. But if we will see the forces on here, this is very small distance here, this is also very small distance, so the force on this and this will be your cancel each other, because if dipole moment is a minus q here plus q here, so force will cancel here, so resultant force will come here, net force will be 0 and net torque will be also your 0 in this situation. Now come to the third case. In the third, find the torque, potential energy, force between two dipoles kept kept along a same line at distance r. Likewise, let this is one of the dipole P1, another dipole P2, and the gap between these two is your let r. So again, same way. Now, what is the here difference here? This P2 is on the equator in the axial line of P1. So electric field at this point is also your in this direction even. So first of all, in axial line electric field is given as 1 by 4 pi epsilon naught 2 P1 by r cube. Electric field direction is this, P2 direction is this. So potential energy is written as minus P dot E. So that become your minus P value your P2, E is your 1 by 4 pi epsilon naught 2 P1 by r cube. So potential energy given as 1 by 4 pi epsilon naught 2 P1 P2 by r cube. This is the potential energy. Now the force. Force, if I am talking about, minus du by dr. By differentiation, this you will get minus 1 by 4 pi epsilon naught 6 P1 P2 by r to the power 4. And if we are talking about the torque is equal to your P cross E, and here angle between the P and E is 0. So modulus of torque is your PE sin theta. Since theta is 0 degree, so torque will be here 0 degree. So there is no torque acting in this direction in this case. So mainly potential energy and force acting. Negative sign in the force indicate your this is the force of attraction between the two dipoles. So this is the different type of dipole and their orientation and their interaction energy